as usual. Today, we shall have some noise in the background because we moved to a certain town school here in Pidge. We shall talk about the details later. We are going to look at biology today, and specifically, not as usual, practicals, paper 2. We very well know that, in fact, the sciences we have made it the simplest. But we as learners, we usually find it hard because we are not well guided. As usual, we, Muto Online, we decided to take you through all these guidelines on a free cost. All we want from you is just to subscribe, like our videos, comment. We shall always keep together. Invite more of your friends. Share our videos, other friends of yours. You can even talk to parents if you can't access their children. You can talk about Muto Online, even where you go. You keep our friends even when you go back at school. I know you have Wi-Fi and computers at school. Please keep checking on us. We shall keep updating you always. We are going to look at biology today, and I want us to simplify it in the biology practical. I want us to realize that any one of us can pass this biology. I'm doing this because I'm waiting for some members to join. I want to start with some reasonable number. So, there are people I don't see yet. I'm waiting for some members to join us so that we can roughly move on. Yes. Not to waste time, we can pick away from there. Biology has 2 papers. We've already said this. We have paper 1 and the paper 2. This is a theory paper we have already talked about, and this is a practical paper. We've been already talking about the theory paper, and we covered a number of topics on theory, and we shall cover more. By the time you go back to your respective schools, I want us to go through these practicals and soften it to a level that every one of us can at least attempt something out of the practicals. So, the practical paper, whether you do paper 3 or paper 2, it comprises of 2 items. And all of these items are compulsory. These 2 items are set from 2 elements of construct. The first element of construct is the physiology. And the second element of construct is about the anatomy of animal and plants. So, when we talk about physiology, I want us to break down this practical. When we talk about physiology, we are going to look at the functions of different parts of the animals and plants and the processes that occur in the animal and plant structures. We are going to look at the details of how the different structures of animals and plants function and the different processes that occur in the different structures we shall talk about. Still, under this, we shall look at a number of sections of biology. And these will include, we shall have some practicals from transport. And these practicals will include practicals of osmosis and practicals of diffusion. We shall have practicals from nutrition and physiology, where we shall have a look at food tests, and then we shall have a look at enzyme activities. We shall be able to access all these things. We shall have a practical or practicals from soil science, where we shall have a look at practicals of capillarity. We shall have a look at a practical about retention, practicals of drainage, practicals of testing soil pH, and so on. All practicals about the soil science shall be covered under physiology. Let me think. We are seeing some of the members joining, and we are grateful. We want even more new members to also join. So we shall still look at practicals of anatomy, a number of them, and here we expect very many. We looked at plants. We shall look at the plant structures, plants and their structures in details. So we know the types of flowering plants, where we have the monocotyledonous and the dicotyledonous plants. We shall have a look at the structures of plants, the different structures, like the leaves in details, the flowers in details, the fruits in details, but in a competence-based way. Let me think I'm clear. We shall look at the different animals and their structures. Not to forget, before we go into the details of these ones, we are streaming in live from a school called MPG Progressive. It is a secondary school located on the main road as you're heading to Masaka in MPG. It has center numbers for both O and A level. A school with one of the best views I've met. It is on a hill. I've seen playgrounds on a hill my first time. I've found an equipped laboratory. They are the ones we are going to use for these practicals, which I'll show you. The tuition, I've been told the tuition is friendly, and I've been told that it accommodates both girls and boys, day and boarding secondary school. Not to go into details, These practicals we are going to look at, all the practicals you do are known as science process skill practicals. What does this mean? It means that as you are reading the scenario, know that in a science process skill practical, it requires you to do the following, or to put the following at the back of your minds. One, you think you should put it at the back of your mind that at a certain point, you will have to plan what you're going to do, because everything is to be done by yourself. As you read the scenario and the planning, know that at a certain stage of this practical, in the duration given, you'll have to implement your plan. As you're planning, you will think of, how am I going to do this practical? What am I going to use? Where are they going to be used? And when will I use this? Then, as you are implementing, what should come in your mind is, how am I going to use what I've planned to use? For what? What do I expect? As you're planning to do, as you're implementing. So, as you're carrying out a practical, you must be with a thought of result that you expect either to get or not to get. That's why we are going to see that in the planning stage, it is where you state an hypothesis. You should also think of how you will analyze the results you get from implementing the practical or the planned work. You've got certain results. Are they connecting to a solution to a problem that was stated in the scenario? We are introducing the practicals to those who haven't started it yet, or started the practicals yet. And finally, we shall expect people who can interpret the results obtained. Yes, you have analyzed them. Can you interpret them in line with what is required by the examiner? And this analysis this interpretation will involve use of certain data analysis schemes such as plotting graphs, calculations. Can you connect your results to a conclusion, to a solution that was needed in the scenario? So it's what the other things we are going to look at. So to respond to physiology items, the items we stated at first, we should know that one should be able to state the aim. The aim of an experiment he or she is to carry out. One should be able, I'm going to define these ones, but let's first know them by numbers. The aim, one should be able to state the hypothesis. So this is senior one, work. The hypothesis. One should be able to state the variables if the practical is quantitative. So we are going to look at the difference between quantitative practicals and qualitative practicals. So one should be able to state the variables he or she is to follow when carrying out the experiment. One should be able to state the requirements he or she is to use. One should be able to state the requirements, the procedures to be followed when carrying out the experiment. One should think of the possible risks and their mitigations that are likely to occur during the experiment. One should know how to present results. How to present the results. One should be able to analyze the results obtained. One should should think of a conclusion based on the hypothesis and the results. The conclusion is based on the hypothesis and the results obtained, the analysis. And finally, sometimes a recommendation. What do you advise someone to use alternatively? What could someone use? What can someone do? Should this someone continuously use that as stated in the scenario? So these are the things one should put at the back of the mind before you even start responding to anything in a practical. All of these must have appeared somewhere in your physiology items as part of the responses. So we are going to see one by one, what does each of these ones mean as we are stating the possible way of presenting this information as a response. So one should state the aim. Let's mention them together. Aim, hypothesis, the variables, requirements, procedures, risks and mitigations, results, analysis of results, conclusion, and then a recommendation. We get to them. We are going to use them. We are going to use these ones much as we are replying to physiology items. Only if you have any question before we continue. So these are the steps of the response when responding to any qualitative or quantitative physiology item. If there is any question. No questions so far? Nakachwa Margaret is saying, well, letters on the BB are not clear. Maybe now they are clear. Let me think they are clear now. Shalom is on. Sender G. Godfrey is appreciating. That is great to hear. So to move on, let's start by understanding what these things mean. I've not seen Zahala yet. Haven't seen Timothy yet. Matilda is not on yet. Red zone is off. Uh, Richard is off. I don't know why. Remember why it is. You notify me that you're on. I want us to understand these things better. Let's start with the aim. What will always the aim mean? The aim will always represent the reason, will be the major reason to why you are to carry out an investigation. The aim will be that reason. So you will always state that I'm going to be giving you the meaning and how we usually give the responses. To me, this is how I train my learners too. So my learner always, on the first line after writing everything, the name and so on, they put aim, and then they put that semicolon. We've said the aim is always the reason why you are carrying out an investigation. So let us assume the aim of the experiment is to find out which food nutrients are absent in a certain food solution. Maybe this someone was presenting symptoms of a certain deficiency disorder. A certain deficiency disorder. So my aim will be to find out, or an experiment to find out, or to investigate which nutrients, which food nutrients are absent in a food solution C. Assuming. Now this one is becoming my aim. It is becoming the reason to why I'm going to carry out this experiment. I'm going to show the reasons to why I'm going to carry out the experiment. So the aim becomes the reason to why you are carrying out the experiment. An experiment to find out which soil sample retains water for a long period of time. An experiment to investigate which solution contains more water than the other. The reason to why you are carrying out an experiment is the aim. So it's better you first know this information before we use the apparatus. So we said we do these videos to even bring those on board who know nothing. The hypothesis is simply a theoretical prediction of the possible results that is yet to be proven practically. The word hypothesis will always mean any theoretical statement you give, so long as it is in line with the aim. But predicting results, whether right or wrong, so long as it is in line with the aim, will be an hypothesis. So for example, my learners always come and say, the hypothesis we don't underline because we are not making notes. The hypothesis they always, for example, they may say food solution, no, reducing sugars, for example, reducing sugars, starch, and non-reducing sugars are absent in food solution C. So an hypothesis may be a null hypothesis or a true hypothesis. I may alternatively say food solution C lack certain food nutrients, certain food nutrients. That can be an hypothesis. So it is simply a theoretical prediction of the possible results that is yet to be proven practically. Is what the word hypothesis means. Let me think I'm talking. I welcome you all, and I'm welcoming questions before I go further. If you have any question, please present it. Welcome Nakachwa. Welcome God Pro. Aro, Shalom, most welcome. Sendagi. Basically, they are the ones who are texting. But you notify us so that we know your presence. Then the variables in these kinds of practicals, we are talking about the physiology practicals, the variables will be the measurable quantities, will always be the measurable will be the measurable quantities in the experiment or in the investigation. Whatever you will be able to measure in the investigation will be a variable. The variables are of three categories. The variables may be controlled variables if they are kept constant. If kept constant. If they are to be kept constant, they always be referred to as controlled variables. Those measurable quantities in a practical that will be kept constant so as to proceed with the experiment well, they will be termed as controlled variables. There will also be, we shall also have what we call independent variables if they are valid. Sometimes the word varying means changing. So the quantities that will be changed in the experiment, we all started physics. We know what a quantity means. We know what the word quantity means. Anything that can be measured. In terms of magnitude is a quantity. So whatever that will be, that is measurable in the experiment, for example, time, temperature, volume, all of those things that can be measured, but changed so that we can get results in an experiment, will be termed as independent variables. And then the variables may be dependent if they are the results of the investigation. Excuse me. So they will be dependent if they are taken as the results of the investigation. So we have three categories of variables: controlled variables, independent variables, dependent variables. The controlled ones are the ones that are kept constant throughout the experiment so that they do not affect the results. The independent are the ones that are valid or changed so that we can get results of an experiment. And then the dependent variables are those quantities that will be obtained as results of carrying out the experiment. We can take a common example, a common scenario of a soccer game. Let's take the recent soccer game. Or we take netball for the girls who don't know soccer. Recently, Man City was defeated on 1-2 to lost to Manchester United by 2-1. Do you know why Man City lost? Do you know why United won? So I'm going to take this soccer game as, so Man U won by 2 goals. So Manchester United managed to score 2. Man City managed to score 1. So we want to get the difference between these three variables. All of this game was played on the same soccer pitch, and that soccer pitch is at Etihad Stadium, with the same dimensions on all sides. The pitch has the same dimension. The pitch has the same size of goals. They all play one half the other side, one half the other side of the pitch. Each team uses 11 players at a time. The team has equal rights of changing players and tactics. They are not restricted at all. All teams are not restricted to use any material of a jersey or a playing kit. They are not restricted of the number of coaches on the touchline. They are all ruled by the same ruling bodies. The referee, the center referee, the linesman, the fourth official, and then the video assistant referee. All of those things are kept constant, I've mentioned. So in a soccer game, whatever I've mentioned is a controlled variable. Same number of players playing on the same pitch for the same number of minutes. They are all kept constant. So they are the controlled variables. But what had changed such that Man City loses to United? What are those things that change to obtain results? One, the tactics. As Man City was using a formation of 4-2-1-1, United was using 4-3-4-3. So the tactic was different. All of these things are measurable, but they are determining the results of a game. So the tactics were valid, were the independent variables in this game so that the teams can get different results. As Manchester was using 4 back players, United used the 3 such that it attacks more than it was defending. So number of players in every playing field or playing section of the field became also an independent variable. 2, the quality of players. Manchester had very nice players in the back, in the midfield, than in the back. United had very good players in the midfield and at the striking. All those determined the results, they were valid such that the results can be obtained. And the dependent variables for this experiment or investigation were the number of goals scored, the results. Manchester scoring 1 as United is scoring 2. I'm sorry to the United, to the Manchester fans and Arsenal fans. She's what? She's what?
Zahra is on.
Zahara, I'm so grateful you're on and you're with us. Let me think. I've tried to simplify the thing about variables. If you have any query about variables, please. There is a question from Jemima Nakawes. Jemima is an active member. I'm so grateful with you. Jemima is asking, does the dependent variables depend on the independent variables? Yes, 100%. Because if the independent variables are not there, we could get the same results. So the independent variables are always valid so that we can get results. So the dependent ones greatly depend, as you hear the word depend, are greatly determined by the independent ones, not the controlled ones. Let me think I'm clear. There is a question from Timothy. Sosa, what you mean is that the results of our hypothesis is the dependent variable, not the results of the hypothesis, the result of the investigation, the result of the general reason why we are carrying out the experiment. The results of our aim are the dependent variables. So what we shall record in the table of the dependent variables will be the results, will be the dependent variables. Nachito Sanya, I'm so grateful you're with us, and she's asking, independent and dependent variables are still confusing, though. Thank you, sir. Let me come again so that I can bring Sanya on board. Nachito and friends who are like you. Let me use a common example. Which example? We have person A and person B at the starting line. They must run from a certain point X to point Y. These 2 points are distant from one another. Sunny, I'm answering you, please. I want to soften the independent and the dependent variables. This the controlled variables are going to be the distance these 2 people are to run. They are starting from the same point, they are finished at the same point. Our target is to have a winner. So the dependent variable will become the time this someone has spent on the way. If person A takes 4 hours to get to point X, and the person B takes 2.5 hours, sorry, to get to point A, to point Y. It means that person A is person B is faster than person A. So the dependent variable becomes the speed of the two people. So the independent becomes the speed. So the speed these two people are using is different. And the dependent is the result, the time taken by these two people on the way to get to the finishing line. We go back to Netable, you understand, Samia. The independent variable is the strength of the team or the qualities of the players you have in the team. If the players are good, so or better than the other one of the other team, it means your team will win. So the result of your game is winning, and it becomes the dependent variable. What is valid for one team to win is the quality of players determining the strength of the team. I think I'm bringing it clear to you, Sanya. Have I answered you, please? So there is a question here. We welcome to Gumisirize. Rosemary, we are so grateful that you are joining us. Naka which Fiona is asking, are the apparatus used in the experiment also regarded to constant variables because they do not change? The variables are, the apparatus are not measured. So don't measure the apparatus, hence they are not variables, please. There is another question from Nantambi Zahala. Naka, which have I answered you, please? The apparatus cannot be variables because we don't measure them. They are not measurable quantities in the experiment. We are talking of quantities, not the requirements. Can the independent variable also independent variable? Yes, the speed, Timothy, yes, you're good. The speed someone is using to reach somewhere is the independent variable, is determining the dependent variable. So the speed someone is using is determining the result. So it becomes the independent variable. Timothy, still, I got it, sir. Thank you. Thanks for following. Fiona is saying, so if the result do not match with the hypothesis, then the answers are wrong. Or I answered you. I told you the hypothesis. The hypothesis may be wrong or right. It doesn't matter. Zahara's hypothesis does not need to be correct or wrong because it is just a prediction. Very nice from Zahara. We said the hypothesis is a prediction. It doesn't matter whether it is right or wrong, so long as it is in line with the aim. Let me think I'm putting everything clear to everyone. And to me, when teaching my learners, I always tell my learners to make a table. That's what I always do. They always make a table. They say variable. I'm now on the stage of variables. So they come down and make a table of this kind. So in the table, they have a variable and the description. I'm showing you how my learners always present the work. So in the table, they say, I'll give the controlled variables here. So they close the table. Even before now, I'm on the stage of planning. I've read the scenario, I've understood it. I'm now planning. So they prepare where they will put the independent variables. And then they also prepare where they will put the dependent variable. They always make a table. So the descriptions of the controlled variables will be put here. If I'm to use the example I gave you, the controlled variables will be number of players playing at a certain time per team, the size of the playing court, the size of goals used, and halves of the games. The independent one will be the quality of players and the tactics used, the ones that are valid. The dependent will be, the results will be the number of goals scored per team as descriptions. Let me think I've made it clear. If my aim was to know which of teams A and B is stronger, that is to find out which of the teams A and B is stronger. My hypothesis, I may say, team A is stronger than team B, because it is just a prediction. For some reasons, I may predict A is stronger than B. But when I come to the table, in my controlled variables, I'll have the number of players per team, size of the playing field, things I'm going to be keeping constant in the experiment. Size of goals, and so many other things that are kept constant in a game. The independent will be the tactics used per team, and then the quality of players. Yes, they are 11, but are they of the same quality in every position? So these two determine the results. They are the ones that vary so that we can get results. Then the overall result of a game that will separate between a strong team and a weak team will be the number of what? The number of goals scored. Basing on the scenario, if the scenario is asking you to carry out an investigation and find out which team is weak, so the independent variable will change. So you will come and say, as number of goals conceded by each team. If they are telling you to find out which team is stronger, the variable, the dependent one will again change and say number of goals scored by each team, such that in the conclusion you will say that the team that has scored more goals and possessed the ball for a long period of time with a big percentage is stronger than the other. So the dependent variable depends on the scenario, the intention of the examiner. What is the examiner intending to know? I'm sure I'm answering you. Great. That is what my learners do. Again, we only represent the variables if the practical is quantitative. If the practical is quantitative, when it is dealing with numbers, determining amount of something, determining distance between certain destinations, certain points, But if we are dealing with quality, the practical may not need these variables because they will not apply anywhere. We may have the controlled variables and maybe, anyway, we may present them, but the variables are more likely to be presented in the qualitative practicals. I mean, quantitative practicals, things to do with numbers. So that is about variables. I think I've softened them. When we move on to requirements, the requirements will be those materials and apparatus that will be used. We use them to carry out the investigation. So the materials, why am I separating the materials from apparatus? They are different. The materials will be those things that will be part of the product, and the materials, they will be the ones that will aid us, will help us, or that we shall use to mix the materials so that we can get the results or the product. So the ones that we shall always need to carry out an investigation will be the requirements. These requirements, we usually state them by numbers. That I will need 2 spoons. Let's assume you are to make juice. And these 2 spoons must be clearly indicated in the procedures, the use of each of these spoons. One for maybe for scoop. They do My learners always do this just to have some organized piece of work that is presented. We are trying to soften these practicals. My learner, to move on, we move on to the procedures. For the procedures, it is merely the set of steps to be carried out when carrying out, the steps presenting how the apparatus, how the requirements were used to get results. The set of steps showing how the requirements were used so as to get results. And these procedures should be presented in a reported format. Not praising oneself that I did this. Not instructing the examiner that he do this, but in a reported format. For example, 20.0 cubic centimeters of a solution, or of solution, let's say of solution C, were transferred, or were done anything into a conical flask bringing the apparatus used to measure this volume, for example, using a measuring cylinder. I'm writing in a reported format. I'm not praising myself. I'm not instructing the examiner. You may find someone may say, I transferred 20 cubic centimeters. For that, you will be praising yourself. You may find someone saying, transfer 20 cubic centimeters of solution C. For that, you will be instructing the examiner to do something. But these procedures are always given in a reported format. Let me think I'm clear. We shall have a number of questions to try out. I'm trying to simplify the things, the steps of a response. So far, I'm here. To move on to the risks and mitigation, we always give the possible accidents and faultiness in results expected. We give the challenge we expect in an experiment, the effect of the challenge, and the impact to the challenge. That will come from the effect of that challenge. For example, the challenge, the accident may be contact of the chemicals with the skin, so the challenge is the contact of the chemicals with the skin. What is the effect? Leading to corrosion that may result into irritations and sometimes wounds, which may lead to pain in that part of the body. You give the effect of the challenge, the effect, and the impact, and then state the mitigation. Still, my learners still make a table. They put risk, mitigation this side. They make simple table with risk, mitigation. You at least give two. Then even results. The results they always make a table to write for results. My learners always make a table to represent the dependent and the independent variables. For example, if someone was varying time, it's the variable, the independent variable he gave. So this time someone will come and give time with the units, standard units usually. Then he presents the variables this someone used. We shall do a number of examples to try out so that we can get to know. And then the expected dependent variable, the temperature, for example, the temperature of the solution in degrees Celsius. So the results are always represented in a table. The results should be put in the to the standard number of decimal places as required in the science curriculum. For example, if temperature read by a thermometer is to 1 decimal place, let your values be 1 dp, ensuring correct units. If you are to use abbreviations in the table of results, these abbreviations must be defined, well defined in the procedures. If not defined in the procedures, come and use the real words you used in the procedures. If you are to give more than one result, you must have indicated it in the procedures that there is an independent variable you valid and the magnitudes of the variation is given. If you valid the time, the values of time change must be presented, that I was recording temperature every after 2 seconds. This must be recorded, must be well represented in the scenario, in the procedures you stated. And then the analysis is usually calculations where necessary. Members, before I go further, these results, to have a practical that is working, the sets of experiments one must have done should have been more than 4. Should have been more than 4. So this is set 1, set 2, set 3. They must have been more than 4. That's when we can get real experiments. Because if you don't know the results here, you will get closely you get closely to know the results here. You will try to perfect here. You will be perfect in the 4th, and you will be very perfect in the 5th experiment. That's why we do more than 4 experiments per investigation. So the analysis of these results may be calculations, may also involve plotting a graph, yes, maybe involving plotting graphs. I think these are 2 major ones. And if you don't mind, allow me start from there in the next session as we are trying out an experiment. So I'm online if you don't have any question. But if you have a question, let me first go through the questions before we end the session. So someone was saying sound muted. I can't hear sound. Let me hope you hear me now. You people hear me? Yes, someone is asking how long does the experiment take? The experiment, you're doing the paper for 2 hours. And the paper of biology has 2 numbers, 2 items. So this number 1 of physiology, we don't expect you to do it for more than 1 hour. So everything should be planned within this 1 hour for this number. Or 1 hour, 10 seconds, 10 minutes.